If you want to learn how to create this high quality portfolio piece, grab your buckets and shovels right now, because we are going to dive into the world of stand simulations, where the only limit is your imagination. Well, right after your computer's processing power. I will break down this scene step by step, and this method is also quite customizable, so you can create something like this with the skills you are about to learn. I will keep this mostly Blender tutorial, but for the sand simulation we will be needing Houdini, since Blender isn't quite there yet with the simulations, unfortunately. This was actually meant to be free for all tutorial before I realized that the free Houdini Apprentice version has a limitation, which won't allow you to export the simulations. So if you can get your hands on licensed Houdini, you are welcome to follow along. I'll try to keep this an easy introduction to Houdini, so I won't go through the whole process in that software, but instead I'll provide you the Houdini project file and show briefly which settings you might want to play with to come up with the different results, just so you can modify the simulation for your needs. So this will be great for those of you who want to take your renders to the next level and add Houdini to your toolset. My name is Tommy, and I think our default cube is waiting anxiously to be deleted already, so let's get started. Okay, so we will be using cycles and also 24 frames per second. And the most important step, delete your default cube. Then we're gonna need something that collides with the ground. In this case, I used a character from Mixamo, but you can basically use your own character or actually any animation you like. I'm going with this zombie crawl one because there's a lot of interaction with the ground. You could loop it in Blender, but because, you know, I'm lazy, so I'm just gonna max out the dream value here so we get more frames to our animation. You should download it with the 24 frames per second and with the skin so we get the mesh as well. Next, just save it somewhere on your hard drive and let's jump back to the Blender. Import your downloaded character to Blender by navigating to File, Import 10fpx and locate your file. When it comes to Mixamo animations, it's a good practice always to tick this automatic bone orientation. It just helps if you want to modify your animation and rig it. And voila, there is our character. And it's desperately trying to crawl out of the viewport right now. Check where your last keyframe is. And type the value here. So for me it's 247. Then our next goal is to export this as an Alembic file. So right click on your armature and select the whole hierarchy. Export it as an Alembic. Give it some really original name like I did here. Also remember to tick only selected objects and just export it. Let's also save our Blender project at this point with even more original naming. Great. So now comes the fun part and we're gonna jump to Houdini. So if you haven't installed Houdini yet, now would be the time to pause the video and do that. You should also download the project file. There's a link to that in the description. I guess just a quick overview of the UI would be at place here. So on the left we have the viewport and down here we have the timeline, which is pretty self-explanatory, I think. This on the bottom right is our network editor. You can think of it as Blender's node editor, just with the difference that the parameters of the selected node will be on this window here. And it also works from top to bottom instead of left to right. Then on top we have this shelf, which is basically for adding items, but we really don't have to worry about it now. And on the bottom of your viewport, you can see the keys for navigation. Okay, so I think that's that in a nutshell. Let's open our sand tutorial file by going to File, Open, and locate the file and open it. Okay, so I have made these 4 node groups here. This setup node includes our character and our sandbox. This simulation node obviously includes our simulation and settings for it. And the export node includes our node tree where we can export our simulation back to Blender. Finally, we have this ground plane node, which I will come back to later. This red triangle here means that it is missing our collider. So let's add the Alembic which we exported from Blender. Double click the node to open it. You can use scroll wheel to zoom in and out in this network editor and middle mouse to pan this view. This node tree on left is for our collider / character, and the right one is for our simulation box. On top of our collider node tree we have an Alembic node. So if you click that and then come here, we can search for our Alembic file. Just locate it and click accept. You can always click this eye or this blue zone here, and it will show what happens in your node tree till that point. So it basically visually ignores nodes after this node. Now you can translate or scale your character and the simulation box from the transform node. You can either type the value here or click it with the middle mouse and drag it left or right. Although I recommend you move your simulation box only, so we don't have to eyeball the location of our character in Blender. Try to keep the scale of your simulation box as small as you need. I'm gonna go to the side view here and check how our collider sits on this simulation. Remember that this defines how deep your animation will sink into the sand. The scale of this simulation box will affect the calculation time. The bigger it gets means more grains, more calculation. And speaking of calculation times, I'll show you the other setting that will affect it a lot. So if you press U key on your keyboard, you can go back one level at a time in our node hierarchy. Or you can just click straight to the root from here. So let's open our simulation tab and click this Vellum Constraint Grain node. Here we have our grain size, which is basically the resolution of your simulation. You might want to play with this one to see what your PC can handle. But be aware, after you start going under 0.01, you should prepare yourself some serious calculation times. After a lot of experiment, I did the final baking with the value of 0.003. And it's about as much as I can push out of my PC. But before we get to the final bake, we want to bake a lower res version for setting our Blender scene ready. Because the high res version will slow down a viewport a lot in Blender. So I probably do my bake at this point with 0.04. And you should memorize this value or even write it down because we are going to need it in Blender. Jitter scale just tells you how well those grains are in order. I prefer to leave it at 1, although you might want to keep it at 0 while setting the simulation up, because it speeds up the calculation times. So now, let's jump to this .NET node, which includes more interesting settings for simulation. There is like 2 main settings that you only have to play with, and those can be found inside the Vellum Solver node. So here we have the repulsion weight and attraction weight. Repulsion weight, it's a bit harder to explain, so I made this video here with the different values so you can get a better understanding of it. This parameter basically tells how many particles will collide with each other. At value 1, all of the particles will collide, and at the value 0, none of the particles will collide, which basically means that with higher value, those particles tend to act in a more chaotic way. This repulsion value here is, in my understanding, I might be wrong, but it's just a multiplier for the repulsion weight value. So attraction weight. Here's the same video with the different attraction weight values. This tells Houdini how many particles will be clumping. So in other words, 0 will mean kind of like a dry sand, because none of the particles will stick to each other. and at the value 1, all of the particle will stick together. You might need to increase this value between our low and the high-res simulations, because whenever we raise the particle amount, there will be less clumping, just so you know. Here's a few examples of combined values if it helps you. So I use these values in my final bake. Then there's also this interesting setting inside the volume constraints node, which is this constraint type. There's plenty of them, so I won't go through those, but you can just try this. For example, the glue is pretty fun one to play with. Then next we have max distance. If you don't want those grains to stick on your collider, you can set this at value 0. Here's an example how it works. So on the left we have a scene where the max distance is set to 0, and on right the value 1, which looks actually pretty ridiculous. Then there's this stiffness value as well. I would leave it as it is, but you can play with it also if you want to. And finally, if you scroll up and select the comment tab, you can adjust your sub steps. Increasing this just calculates more precise simulation, but it will also come with the longer simulation times, so be aware. And I believe we went through every setting you need to know. Oh, I almost forgot. Every time you change one parameter, it starts to calculate the new animation. So if you don't want that, just change this auto update to manual. So finally, it's time to simulate our animation. You can do it by previewing our simulation from the play button, but because the viewport renders might run slowly and also run out of the cache memory, I recommend highly that you select the view you like and click this flipbook icon here, and that's the better way to preview simulations. Oh yeah, and one thing, this ground plane, which I talked about at the beginning. So now if our grain here lands on our simulation box, it'll be fine. But if it misses, it will fall to infinity. So if you don't want that to happen, we have this ground plane here for that. You probably need to modify the ground object depending on your simulation size. Open the ground plane node. Click this blue zone again and translate it so that the plane will be on level with our sand. Next we have to make some sort of pool for these grains here, because if our plane is intersecting with the grains, those will go just haywire. And now, if there's any Houdini artist watching, just cover your eyes, because I have no idea how to model in Houdini, so this is how I did it. Try using scale and translate values here to get our faces roughly matching to our simulation size. Then I activated the edit node and I click the selection tool and select these faces. Select poly extrude from polygon tab up here and drag our faces down so our grains can fit in. It looks like we have a little bit of intersection here, so I'm just going to scale our plane on x-axis just a little bit, but you probably get the idea here. Just make it as perfect as you can. Then there is this final step, because our ground plane is not active at the moment, but let's change that. Navigate back to our .NET node, and from here you can just connect this static solver node to the merge node, and it should work now. I will take a quick flipbook render here before we go to export. And I think it looks good enough. And as you can see, now our cranes are landing on this ground plane here, so that's good. Okay, so it's finally time to export our simulation, which is actually made really simple here. Let's go inside the node and you can set the frame range you want to export by typing the last frame here. And if we now look at our ROP Alembic node, it should have updated the frame range here automatically. Then from here you can select where you want to save it. I just continue here being creative with the file names. And guys, remember to include the file extension in your file name so it ends .abc. That's just how Houdini works. And actually it would also be a wise move to save our project before exporting. Click Save to Disk, and now you can give yourself a pat on the back because you survived this far and we are done in Houdini for now. We will come back later though to bake the high-res sim with more cranes, but anyway, this is gonna calculate for a while, so I'll see you back in Blender after this finishes. So let's import our simulation. Well, you know the drill already. Let's use our creativity once again to name this object something original. Okay, so our next goal is to blend our sand simulation to our environment. And let's start with creating a cube, which will be our parent and Boolean object. So Shift A, add a cube, and let's change the viewport visibility to wire so we can see inside it. Let's also disable all these from render as well. Great. Now let's size it just so it's just a tiny bit smaller than our sand sim. On Z-axis, it doesn't have to be so precise, but try to place it so the sand sits on top of the bottom face. Now I'm gonna select my armature hierarchy, then the sand sim, and last our box. Ctrl B and to object and keep offset. And now we should be able to move everything just by moving our cube. Perfect. Let's create our environment next. So thanks to Greg Saul, I did pick up this beach HDR from polyhaven.com, but you can use whatever you like. Obviously there should probably be sand, snow, mud or something similar on the ground to make this effect believable. I recommend using at least 4K res for this, but optimal would be like 8 or even 16K. Let's start by creating our environment by adding a UV sphere to the scene. I'm going to scale it 20 times for now. I'm gonna also name it as a dome. And let's actually make it the dome as well. But before that, I'll just name our cube as a controller. In front view, I select all the vertices below x-axis and delete them. Now select the outer edge loop and make a face there. Then inset it and make it something like this. Then delete this face and select this edge loop. Hit Ctrl F and use grid fill. In my experience, the Boolean might work better if you have these middle lines here perpendicular to X and Y axis. So if you didn't get those automatically, you can just adjust this offset value. I'm also going to give a bit more geometry for these ground faces by subdividing it once or twice. Remember to apply the scale. And finally just bevel these hard edges a bit. Let's also shade the whole dome smooth. Okay, so now we have our dome, and next we want to assign our HDRi map to it. give it a material, name it dome. So let's open our shader editor and let's start creating our material for the dome. If you have a Node Wrangler add-on enabled, you can just press Shift S, and it is a handy way to change the active shader to something else without needing to delete and add a new one. Let's change this principled BSDF to emission and add the environment texture. Ctrl T to give this node texture coordinates and mapping nodes. Change the coordinates to object and select the dome as an object. Well, this dome makes the navigation pretty frustrating here pretty fast while you're gonna bounce in and out from this dome like this. So let's just quickly make it more user-friendly. Since we will be working inside this dome, and well, I might as well just show you. So our normals here are pointing outside at the moment, and if I just fly inside our dome, actually I'm just gonna make here a hotkey for walk navigation and assign it as in Shift F, because that's what it used to be back in the days. So it'll be all red faces inside the dome. And you always want the blue side to point on your camera. So we need to flip our normals to point inwards. I select all the faces and hitting Alt N and flip. Now we can come up here and activate the backface culling. So it's basically makes every red face invisible. I don't really know what's Blender's logic here because this works only for the solid mode. But since I like to work a lot on the rendered mode also, I need to make the same effect in the shader nodes. So on the shader editor, we just have to mix our emission shader with the transparent shader. And then use a backfacing as a factor. And there we have it. It's much easier to navigate in our scene now. But our ground here looks a bit stretched, I would say. Now you can adjust the location of the HDRi on a different axis. I'll just leave X and Y axis at the origin and adjust the Z location so that we get our horizon roughly where the ground and the sky meets. Actually, I'm gonna zoom a bit here and I'm gonna make it so that those footprints on the sand are about the same size as our character's feet. Also gonna rotate this texture on Z axis and also gonna place my camera here. Alrighty, now our ground looks awful. I mean, it looks kind of fake at the moment because it's emitting light and that's why it doesn't have any shadows on it. So let's duplicate our dome material. Name it maybe like dome ground. And let's assign it to our ground. Okay, so it looks like our backface culling is not helping us here, but I think we'll be fine. So let's select this middle vertex and hit Ctrl+ as many times as you need. And just assign it to these ground faces. Now we want our sky still emitting that light, but for the ground, let's change the emission shader to diffuse. And Actually, it looks much better already with the shadows on the ground. It actually looks surprisingly good from this camera angle, but if I move our camera a bit, you will see this horrible color difference between our ground and the sky. And we need to fix that with the gradient mask between emission and diffuse. And here's how you do it. Select our dome material, and I guess we should rename it as a dome sky now. I'm just making some room for the nodes here first, and now we obviously need to mix this emission with the diffuse, so let's add that. And by the way, if you wonder how I mix these shaders that fast, it is just like dragging your right mouse while holding control, and again, it only works if you have the Node Wrangler add-on enabled. Next, let's duplicate our mapping node. Give it object coordinates. Then we're gonna use separate XYZ node, and we are going to use jet as a mask here. And as you can see, it does exactly what we need and creates this gradient here. Now if you feed it to the factor input, our environment should look much better. Except it doesn't because our mask is the wrong way. So let's just add an invert colors node here. You don't have to, but you can also add color ramp node here. So if you want to adjust how sharp the transition between emission and diffuse is. Now you can just adjust the jet location to place your mask as you want. I should probably remind you at this point, after all this hard work, that you really don't even have to use HDRi map for the environment. That's just how I did it, but it's perfectly fine to use an image plane as a ground, or even a sky. It all just kind of depends on your camera movement and position. Well, now that we separated our ground and the sky, you can rotate them individually if that's something that you need. You may also improve the realism a bit with the sun lamp. Let me just delete this default light from our scene, and I'm gonna add a new sun. And I'm gonna rotate it roughly so it matches with the sun on our HDRi. But as you may notice, it doesn't have any effect on our scene even if I crank up this sun strength to 100. And that's because our dome is blocking all that light. So we need to disable some ray visibilities from the dome, and we're gonna do that from the Object tab. And you can just disable all the ray visibilities except the camera and the diffuse. And now it's looking much better. We just need to lower the value here. And you can play with these values, kind of like how sharp you want the shadow to be. I'm gonna make the color a little bit more orange. Okay, so our environment is done, and now we only have to set up our sand simulation to be seen in render. So let's go to our Geometry Nodes tab and select your sand. Create a new node tree, and I might name it as sand. Add mesh to points node here, and it will turn our every simulated grain for this sphere looking sprite texture, which are visible in our render. Now if you still remember which value you gave for the grain size in Houdini, you could type it here. So for me it was 0.04. But it looks like Blender and Houdini use different measurements. As you can see, these grains are overlapping now. So what I found out is that if you divide this Houdini's value by 2, it's pretty much the correct one. But anyways, I like to use something between those values because I think 0.02 is creating too much shadows between grains. So I just use 0.03 here. Let's also give it set material node, so we can use our HDRi map as a texture on it. Select the dome ground material from the dropdown. I'm just gonna move our control object a bit down so this simulation is on a level with the ground. At the moment our dome is also blocking all these trails on our simulation, so we need to make the same kind of pool for our simulation here that we did in Houdini. So for that we are going to use this control cube as a boolean object. But before that we need to give our ground thickness or the boolean won't work. I'm gonna use solidify modifier to give the thickness for the dome. And let's add a boolean and use our controller as an object. You will probably get these nasty looking shading artifacts, but no worries, there is an easy fix for that. Just right click and use auto smooth. Great. Now the dome is not blocking our trails anymore and you'll probably start seeing this scene coming together now. Our simulation is so low res at the moment that you might need to move these after the high res sim, but I'm gonna move this controller just a bit up like that. Okay, our simulation is not blending to our dome that well right now, so we should adjust the colors a bit. These will always depend on your light setup and the camera position, so just try to make it as perfect as you can. Okay, so let's open the shader editor here next to the geonodes and let's duplicate our dome ground material. I'm gonna name it color correction, for example, and add a hue saturation node between your image texture and diffuse shader. Oh, and nothing happens here because we need to set this sand using this new material in geometry nodes. Now do your best with the values here to blend it to the ground. Feel free to use other color adjustment nodes as well if needed. Right, so we are almost done. But if you are planning to take close-up renders, these grains kinda breaks the realism here, as you can see, because our texture is just projected to the sand sim, so it kinda slides here while the grains move, if you see what I mean. I mean, you can probably hide this with the motion blur or depth of field, or if your camera is far away like this. But I already have a tutorial for how to fix this if you want to go more in depth. So anyways, I will just quickly show you here the node setup to fix that. First, let's duplicate our sand. It's important not to move it. Then name it something like sand still. Go to the first frame and apply the Olympic so it's not animated anymore. Actually, activate this icon so it doesn't eat memory in the background and hide the object. And hide it from the render as well. Now select your sand sim and modify the node tree like this. You can drag the sand still from the outliner. Also you should add position and index node. Then add sample index node and connect these nodes. Remember to select the vector from the dropdown. Then add store named attribute node and change it to vector as well. And connect these nodes and give name for it. Finally, feed it through the material node and go to the shader editor. To edit your color correction material, just replace the texture coordinates node with the attribute node. And type the same name here. And now every grain has its own color. This will obviously look much better after we bake the high-res simulation, which we can actually do just in a moment, but few reminders before that. You don't have to do this, but I'll just show you. If you want to adjust, for example, the set value on your dome ground at this point, remember to copy-paste the value to your sand simulation material as well. Our grain size is just so huge at the moment that it's kind of hard to tell if the coordinate matches with our ground here. But it does, trust me. I should probably also mention that you will save yourself from all the hassle if your sand sim sits just in the middle of the scene. But I know that it's not possible in every case, so if you have to move this somewhere else, for example over here, and that's a bug. Glad I actually got it in the video. It appears fairly often if you render with optics device. Well, at least I have never seen it happen to CPU or CUDA devices. But anyway, it fixes itself if you just jump to solid mode and back to render mode. Yeah, so if you have to change the location of the simulation, it won't really blend to the ground anymore because we replaced the texture coordinates with that attribute node before. So you might just play with these values on mapping node and try to find the right spot. But that is really hard. So let's back up here a bit to the middle. Easier option might be to let your simulation be at the origin and play with your ground coordinates. Just always copy those values to your simulation. And now we can see here that these darker footprints are where those are meant to be. So it works as it should. You could always make some drivers here to automate this whole process, but let's not go there this time. I'm just gonna undo all this first. Okay, and after we added the solidify modifier to our dome, our backface culling don't work anymore. So if that bothers you, you can just disable these modifiers from the viewport. And that's that. Save your blend file and let's go back to Houdini to bake the final simulation. Alrighty. Let's open our Houdini project. If you are happy with your settings, just lower your grain size value and export it, but keep in mind that there will be less clumping with more grains, so you might want to adjust the attraction weight here. Okay, so as I mentioned before, I went for 0.003, which will create almost 85 million grains. So this might be a bit overkill, but I fortunately have a pretty capable PC. But you should go as high as you can with your PC. I'm just gonna hit the escape to stop the calculation for now. Just remember to make sure to have enough space on your hard drive. Hi, it's me from the future here, and this simulation ate whopping 502 gigabytes from my drive. So approximately like 2 gigabytes per frame. I will slap all my simulation settings here, so you can just pause the video and copy those if you want. Now just gonna select the path and the file name for it. Oh, and it started calculating the first frame again, so I'm just gonna hit escape again and click save to disk. So now would be a great time to go on a vacation because this is gonna take a while. Choose your favorite destination. Oh, nice. Never been there, but looks nice. Maybe just gonna book my flight here and... Dude! What the $8,000? Okay, I'll just sit and wait instead. See ya in Blender after the baking is done. So here we are, about 30 hours later, and the last frame is calculating, so fingers crossed that it's not gonna crash at this point, or I just might book the flight anyways. I made it. Let's just make a few final tweaks before we import the high-res simulation and render our scene out. First, I'm gonna add a focus point for our camera. Let's just select our armature and change it to rest pose, so this gets a bit easier. I would like to set the camera focus on the robot forehead, so I'm placing my 3D cursor somewhere here and add an empty there. Then I'm just gonna size it down and name it something like focus. Then while our empty is selected, shift select our character and enter in the edit mode. Select 3 closest vertices, and I already have those selected here, so I just hit Ctrl P and make a vertex parent. And now if we go back to the pose mode, our focus point should follow here. I'll just open the timeline here and it looks like it works just fine. Well, then we are ready to add a depth of field in our scene. So in my opinion, you should always use depth of field when you're trying to make a realistic renders. So let's activate it. And you can use this eyedropper here and select our empty to be a focus object. Now you can just play with the f-stop value. By the way, all the tweaks we are doing here now are just fully up to your personal preference, so feel free to make the scene as you want. I just recommend that you don't overdo the DOF. I'm gonna leave it somewhere here, and next I'm gonna just add some life to our camera. So for me it helps to visualize the outcome if I just fully enable this passe part out. However do you pronounce that? I don't know. Then just hit the auto keying and play with your camera. I'm gonna fast forward this part. Okay, so it could be better, but this will do for the demonstration purposes. On top of this camera animation, I use this free camera add-on from Ian Hubert called Shakify. It's free and you can find the download link from the description. There are a good amount of these different real-life camera shakes, but I just use this investigation with its default values. Your camera actually might need a bit of adjustment after applying the shake, so I'll quickly add a few keyframes here. I also feel like this camera angle is a bit tight, so I will lower the focal length to something maybe 35 millimeters. For the trails, we could perhaps use this low-res simulation. Just duplicate it, name it, go to the frame which you want to use. I'll use the last frame of the animation and apply the mesh sequence so it's not animated anymore. Now it's just a matter how you want to place the trails, and I don't need this auto key anymore here. The main thing is that it just sells the scene from your camera's point of view, and the depth of field really helps here to blur out the low-res scene. Oh, and we should actually duplicate our geometry node tree for these trails, because we are going to lower the point size in our main sand simulation, and we don't want that to happen in the trails. Then I also have these photo scans here, mostly from Ian Hubert's Patreon, so I can't share them to you, but I'm telling you, if you are serious about learning some advanced stuff in Blender, you should really join in his Patreon. Plus, you will also get these assets. These are just a quick and easy way to populate the flat ground we have here. I'm not putting too much time on this video, but one thing that I will do is some color correction to them, so those can blend a little bit better to the environment. I just lower the saturation of these rocks a touch. Also gonna add RGB curves node to adjust the red channel. And maybe I'm also gonna give a bit more contrasted. I'll just fast forward this and show you next an easy way to add a fire to the background. I used pexels.com. I need videos and I need fire. And I think I like this one. And I'm just gonna download it. I can do SD quality since it will be blurry anyways in the background. Shift A, image. Oh, we need to enable the images on planes add-on first. So tick. Then Shift A, image as a planes. Locate the video file. Import. Change the color output to emission. Use black as a base color. Drag the color to the alpha input. Adjust it with the color ramp. Add a mix color node here. Make it orange. Use multiply. Adjust the factor. And use the cyclic so it loops. Then just drag it on a place. I did the same with the sparks. Then it's time to unleash your inner Picasso and texture the model with the software of your choice. I use Substance Painter because I'm not really familiar with texturing in Blender. Just bear in mind that it really helps to sell the shot if your character has the same kind of dirt on the textures than your ground is. Lastly, I'm checking my render settings. Max samples, I think 500 is plenty. I might lower this after the test render. I like to use denoise. Light paths, 12 is just an overkill. I don't need those. Activate the motion blur, thank you. Make sure you have filmic selected. I don't want those first frames here. save it somewhere, and now we can import our simulation into the scene. Just selecting our simulation here, and you can change your mesh sequence from here. Okay, and this is really going to slow down Blender now, but let's try to survive here without crashing the software. So it works. Now we need to make a standstill object again. So I'm just going to copy the name here and delete the old one. I'm actually just gonna look how does the render look at the moment. And it looks like he's having some cozy bubble bath at the beach. Okay, so let's duplicate our simulation once again. I'm gonna disable these so I can actually do some work here. Gonna name the duplicate standstill. Let's go to the first frame again and apply the mesh sequence. Then you only have to activate it again in geometry nodes and actually do the same for those trails. Let's lower the grain size in our main simulation. I'm just gonna divide the value that we gave in Houdini by 2 and select some frame here and activate our sandsim to be visible again. Yeah, boy! So we have a lot of grains now. And if you like each grain have a different radius, you can just use the random value to radius input. And did it crash? Okay, so it was just calculating something. So now we have a different size of grains here, as you can see. Let's just see if my GPU can render this without crashing. I doubt that, but you gotta try. Yup, it ran out of the memory, so I have to render with my CPU. I did some post-processing in After Effects, but this video is just way too long already, so I'm not gonna include that here. But if you want to see my post-process workflow, just let me know in the comments and I might make a quick tutorial on that. Okay guys, so I think that's that, and if you create something cool with this, I would really like to see, so please let me know. Until next time, bye.